Yes, good afternoon to everybody. I would like to thank you for the invitation from PAGEV that we are able to take part in this program. And we thought about a subject, and I called my 15 minutes presentation Innovative Plastics for Household Applications, Appliances. And the next 15 minutes, I will spend a very short view on LANXESS. Then I selected some material developments with quite an innovative property profile and bring them in line with some application examples, and we'll end it with a summary. LANXESS is a spin-off of Bayer in 2004. It's completely independent now. The product profile is concentrating on plastics, synthetic rubbers, intermediates, and special chemicals. It's a global operating company with around global sales of 8 billion euro in 2014. The business unit I belong to is called the High Performance Materials, the producing polyamide and PBT, and a huge variety of compounds. And since a few years also we are offering continuous fiber reinforced thermoplastics composites. You find this material in all of the applications from automotive up to E&E applications. This is a slide usually show also some pictures, but it shows the focused market segments can be divided in automotive and electronics, and within the E&E, household appliances is an important market segment for us, where we see potential for the polyamide as well for PBT compounds. Current applications you find our materials are typically connectors, switches, sockets, thermosets, door locks, functional parts, housing parts, as well panel supports. I'm coming now to the polyamide. We developed unreinforced polyamides with a very stable glow wire performance. We are talking here about polyamide 6 and 6,6 containing halogen containing flame retardant system. This unreinforced compounds are used for small electrical applications, used in household appliances, in particular when there are unsupervised devices and the current of larger than 0.2 amp. Then, according to the safety standard IEC 63335-1, you have to conduct the glow wire test at the finish part, and you have to pass. You have to conduct this test at a temperature of minimum 750 degrees Celsius. This safety standard for household appliances is very specific, as it has a specific saying on the burning time. The burning time is here only allowed 2 seconds. And that we call it in the industry also glow wire test without flame. Conducting this glow wire test on test plates, as you can find the data in all our brochures, they are all done on 2-dimensional test plates. But conducting this test on a 3-dimensional part is a different story. And with this material development, you can do the glow wire test independent of the part design. You can do it wherever you want, and you have a very stable performance, and you reach at least 750 degrees Celsius. We have this in polyamide 6.6 as well in polyamide 6, as you can see here on the right lower corner. Of course, the polyamide 6.6 has some advantage in the short-term heat resistance, whereas the polyamide 6 has the advantage of having a higher impact strength. The test conducted on the final part is always a challenge for the part developer, as this test can be only conducted after the final part has been produced. But very often you need to do the material decision in a much earlier time of the development, before you design the final part in terms of snap joints. You have to cut the tools by considering the shrinkage. So the earlier fixing of the material is very important. And polyamide and PBTs, depending on the flame retardant systems, perform different in the glow wire on the finish part. That is related to how the flame retardant system works. I'm coming now to the polyester blends, and here I selected two examples for functional parts. The first one is the one with a very complex part design. Here I choose an example as a shaft carrier for a kitchen machine, and it's a complex part design. There was a basic demand on the material needs to withstand and absorb high mechanical loading capacity. It should have a high dimensional stability, low tendency to warp. It should have a good flowability, so easy processing is available. Easy processing means also at the mold shop having a wide processing window to optimize the molding process. And of course, sufficient chemical resistant. How to do it when you'll go into PBT? Then PBT is always related to somehow challenges with regards to low warpage. But if we want to improve this, then usually we use blends. And this can be with polycarbonate or with ASA, acryl nitrile styrene acrylate. And to have the mechanical properties, it's of course reinforced by glass fibers to achieve high modulus and also higher temperature stability. In this case, the choice was on PBT PC blend with 30% glass fiber, and in this application it was a formulation having also an easy flow package included. With this one we could fulfill the demand on the mechanical loading. With the easy flow package we could improve significantly the flowability of the compound, which lead also to a good surface quality. The inner part, despite it's an interior part, but this area here is visible as soon as you lift up this metal container. So there has been some specific wish to have a good surface quality. See here, why is PBT PC chosen? And here you can see on this simple photos, this is a round plate with a central sprue, and with a classical PBT glass fiber reinforced, you get this typical Chinese head. That means that the corner, due to the orientation of the glass fiber, has different shrinkage values, and that gives this bending of the test plate. With PBT ASA you have already a visible improvement, but the best lowest tendency to warp you achieve is PBT PC, and that was the reason why this compound was chosen here. With the easy flow additive, we could improve the flowability by up to 40%. Okay, that is a theoretically value done by a floral spiral at wall thickness of 2.5 millimeter, and can be only an indication that may be different by different wall thicknesses. But also, we also achieve an improvement in the impact strength by 30%, and that is because we have a very good bonding of the easy flow additive to the polymer matrix. All other properties are identical to the standard grade without easy flow package. And a nice side effect is that with the easy flow version you have even a lower density compared to the standard. This XF, and this is the easy flow product family within our POCAN grade, is called by XF, and this material I introduced just now is part of this one, which we offer as unreinforced and with different reinforcements. The next sample is a polymer blend with improved heat resistance based on PET PBT, and here I choose an example for interior part of air fryer, for the air fryer. These parts are used as heat shield for the outer housing made in polypropylene. You see here the temperatures in the device under service. You have 200 degrees over a longer time, 1 hour, but you also have peak temperatures of up to 250 degrees Celsius. These parts had to pass also of course the IEC 60335-1, and this application is seen as a supervised household appliances. There was also additional tests with regards to dishwasher proof. There was no smelling required after heat aging. And of course there should be also a cost advantage due to the former solutions which has used PPS. As I said, for this was chosen a PET PBT blend, reinforced with glass fiber and mineral, 40% filler content. With the PET, we have increasement in the heat resistance. So with the HDT, the heat deflection temperature is 250 degrees, was sufficient here. The glow via flame index is 750 degrees Celsius, which is also fulfilling the standard. With the PET, we have also improvement in the easy flow, which enables an easier molding process. The dishwasher test was passed, as well as the smell test. We have a further demand from the market in Europe, which goes into the direction of, let's say, a greener product. And how we can achieve that is that we use post-consumer recyclate. And there are a post-consumer recyclate based on recycled PET available in the market with very narrow specification range, which can be used for such compounds. A result is like this, is an Eco T7142 from our product range, where we can show an improved, so-called improved carbon footprint, and we define it like that we save energy costs by 25% compared to standard compounds. Important is, and that was always from the beginning, if we develop this, we need to have identical properties to the standard, using only pure PBT. That was one of the targets we set, and you can see here in this added table that the Eco versus the T grade has nearly no drop in properties. Coming to the end, I have shown an example of an unreinforced flame retardant polyamide with a very good performance in the glow wire test performed on the finish part, and this independent of the part geometry. And that should give the part developer a lot of confidence at a very early stage of the part development. And I also show some new polyester blends with a unique property profile which allow with the use for functional parts with very high requirements, as I have shown it in the two examples. Yes, thank you very much. I hope you find some of the information interesting, and I would like to enjoy then your questions later on. Thank you very much.